All right, let's continue with vectors. We're on 8.7. So yesterday, basically what we did yesterday was to take a vector and to just break it down into its components, correct? All right, so that's the initial. So this is just quick review of what we did yesterday. So that's x1 and that's y1, correct? So the initial point is always the ones. Okay, the terminal point, or the final, sometimes we say in physics, is x2 and y2. And what you have to do is you got to break it down into its components. Do you remember what its components are? Basically, it's this. It's the x and the y. Remember we talked about New York City? And you can only... Please don't. I'm in the middle of talking and you're doing stuff like that. So watch. So this is your x component and this is your y component. So that's what we're doing. We're trying to figure out how did you get from this point to this point if you can only go sideways and up and down. Okay? So what'd you do? You went to the right this many places and you went up this many places. So how did you find out how many places did you go? Well, it's a simple little formula. And they put it in these little brackets. They look like arrows. I don't even know if they have a name or not. They just do it so it makes it look a little different from just a parentheses. Because a parentheses would just look like an ordered pair. So they put these little arrow brackets. Excuse me. Oh, if I get through one more class, I'll be fine. Okay. Get out of my system. So how did we find the x? We went, what, x? Sorry. Right, x2 minus x1, and then y2 minus y1. Alright, and that was the components. And that was basically it, right? That's pretty much what we learned yesterday. Let's take this a step further. Let's just review one more time before we take it a step further, okay? A vector is basically two things. What is the first one? It's magnitude. Right. And its direction. So that's what we're going to do. So the first example we do today, we're going to give a vector, going to put it in a coordinate plane, right, x and y axis, and we're going to find its magnitude and we're going to find its direction. All right, the magnitude's not hard. The direction sometimes gets a little bit tricky, so you got to bear with me a little bit when we get to the direction. Chris, you getting all this? Good. You see through your arm like that? Is that what you're doing? All right. Well, I'm glad things are working out for you that way. All right. All right. Here's this is an example on the top of page 594. So if you want to look at page 594, feel free to do that. And what it says find the magnitude of the direction of vector RT. Here's RT. Remember how we do a vector? It's kind of like an arrow with only half an arrow. I showed you that yesterday, didn't I? Yes? No? Did I show you that yesterday? No. I didn't? Okay, well, there it is. I'm showing it to you today. I thought I did. I did the other class. I thought I did for you guys. Anyway, that's how we show a vector. R would be the initial point. T would be the terminal point. So it starts at R and it goes to T. So a vector, the direction is very important. So normally if we did a line segment, remember doing that earlier in the year, we could say RT or TR. It didn't make any difference. On a vector, it does make a difference because you're starting at R and you're going to T. All right, it makes a big difference. So what we're going to do is give you a couple ordered pairs for R and T. So they said R is the ordered pair 2, 4, and T is the ordered pair -3, -2. All right, so here we go. Now, if I'm given two ordered pairs, what do you think that my first instinct would be? It's to do what with them? Yeah, put them on a graph. Graph them, right? So let's do that. Let's put a few marks on here. This way it was last night when I was trying to go to bed. Couldn't stop coughing. Yeah, no, I'm staying here because you're Alright. I should have stayed home, but I care about you guys too much in your education. I didn't want you to miss out on learning vectors today. So, wasn't that nice of me? Okay, here we go. 2, 4. No, I said I'm going to a funeral tomorrow, but it's not going to be during your class. I'll be here. Don't worry. I don't want to disappoint you. All right, so 2, 4, and this is -3, -2. So -3, 1, 2, 3, and 1, 2. All right, so there's our 2. Let's draw the vector in different color just so it stands out a little bit. So look what we're doing. We're starting from R. This is R right here. Should put the point. And then this is T right here. And we're starting from R and we're going to T. So I'm going to put the arrow down here at T. You guys watching or do you need to leave? Alright, you need to settle down. I'm serious. Okay, I'm not joking around. Alright. So you're going from R to T. And so what do we have to do? We got to find the magnitude and the direction. When I ask for the magnitude, this line, the length of this line represents the magnitude of that vector. Okay, so the length of the line. So how do we find the length of a line? Let's put the ordered pair here. This is 2, 4. Yeah, using the distance formula. And t is -3, -2. That's right. To find the magnitude, all you got to do is just use the distance formula. So I'm going to put a 1 here. I'm going to write magnitude just so we remember what we're trying to find. And so the magnitude is how long that line is, how much of something. So it's just the distance from here to here. If you wanted to, you could draw a right triangle, but let's scooch this over because I will need that room. Let's scooch this down on here. Oops, I forgot that part. Okay, so how do we find the magnitude? Use the distance formula. Let's do it. Do you remember this?
Yes.
It hasn't been that long, has it? The distance formula is very similar to the Pythagorean theorem. In fact, it's taken directly from the Pythagorean theorem. So let's put some numbers in. How do we find our x? Right, you just subtract them. On this case, it doesn't really matter which order you subtract them because you're going to square it anyway, and it's just going to become positive. So 2 minus -3. Can you do that in your head? What's 2 minus -3?
-1.
It's 5. Minus negative is plus. Okay?
Oh,
4.
Yeah.
4 minus, use your calculator then, okay, if that's the kind of answer you're going to get. Watch, 4 minus -2 is 6. Very good. You're catching on quick. So what do we have here? We got 25 and 36. And what's that, 50? 61? 61. All right, so that's the distance, that's the magnitude. So we're halfway done, aren't we? So what's the magnitude? It's square root of 61. Yeah, if you really feel the need to put it into a calculator, it's approximately 7.8. All right. I'd be fine if you kept it square root of 61. All right, are we finished? Is that all we needed to do? No, we got to find the direction. Now watch, you got to watch carefully on this. In fact, I'm going to get rid of this because I'm going to write something in that spot. What I'm going to do, what?
For the direction, are we just allowed to look at it? And for the top of the...
I'm going to show you how to do direction. How many... No, I'm not going to do any of that. That's what I'm going to show you. So just be patient. Let me show you. Okay? And I'm going to draw this way over here like this. Wow, that was pretty good. Alright. Now what I did right here was this. This is where we started, correct? So I want to... let me see if I need to say anything else before I get to this part. Now we'll just do it from here. Watch. I'm going to start right here. Let me show you how we... Let's do this color. How we measure the angle. We talked a little bit about this yesterday. This is the x-axis, and it's the positive x-axis, correct? This would be the y-axis, and this would be positive, this would be negative, and this would be negative x-axis, this would be the positive x-axis. What we do is this. We always start at the positive x-axis, and we go counterclockwise. Remember talking about that yesterday? We go counterclockwise until we hit our line. Okay? See the thing in blue? That's the final angle that I want. So my final answer for the direction is going to be that whole big angle. Well, it's over 180, right? Because from here to here is 180. Plus we have to go a little bit more. Do you see that? It's the little bit more that I'm concerned about. Because I know from here to here is 180. So all I got to do is go 180 plus this little bit right here. But I got to figure out what that is. And that's the key, really, to this whole problem, is to find this angle. All right? Well, how do I find that angle? Well, I'm glad you asked. Let's do this. No, we're not going to get a protractor. I can't believe people say that. Have I mentioned a protractor one time?
Well, yes.
The only time I ever mentioned a protractor when I was yelling at you for talking about using a protractor,
well, no,
okay?
At the beginning of the year, like, the list of things somebody needed a protractor, so I got one. Then I haven't used it yet.
But I never gave you a list with protractor on there, did I?
Well,
Okay, I didn't. I've never mentioned protractor one time in here, so we will not use a protractor on this. We're using our math. How do I know this is accurate? How do I know that all my lines are exactly even and all that? You don't. That you can only use a protractor if you know everything is drawn perfectly to scale. In math books, everything is not necessarily drawn perfectly to scale. So we can't use a protractor. We can't use a ruler. We use our math. That's what we're trying to learn, okay? So even though if it doesn't look like it should, our math still works out. So what we're going to do is make a right triangle out of this. See this thing right here? That's going to be my hypotenuse of the right triangle. Look at this length. This is going to be one of my sides of my right triangle. In fact, let's do this in a different color. Let's go in a darker green. Watch. I'm going to start here, and I'm going to draw all the way until we get right there at the -3. And then I take it from here, and I drop it straight down to there.
Can you just use the y-axis as the other side of the hypotenuse?
I'm going to use this one right here.
The other y-axis is the white one. Can you use
This?
that as the other side of the triangle?
But you don't know how far down you have to go because you're in no man's land right here. Right here, I know exactly how far I have to go down because I know exactly where that point is.
Okay.
I know where I am here, and I know where I have to go. All right. Let's make this a little bit bigger. Oops. There we go. That one. Okay. Do you see it? You see the two green ones? All right. That makes a right triangle, doesn't it? Yes? No? Makes a right triangle. So look what I want to do. Remember the very first thing I did today was a review from yesterday? This will tell you how far over and how far down that you go. What did we do? Let's break this down into its components. All right, so break it down into its components. How did we do that? We went x2 minus x1. So let's take a look at these. Now you could just count over. Granted, okay, you could just go here and go 1, 2, 3, 4, 5. All right, you could do that. But it's not always going to be that easy, so I want to know a nice way to do it, especially if we're not real nice and clear on our graph, okay? If I wasn't as neat as I was, sometimes you might get mixed up. So let's just do it by the math. So let's go x2 minus x1. Well, it's -3 minus 2. What's -3 minus 2? It's -5. Let's do the y's in the same order, okay? We go y2 minus y1. So it's -2 minus 4. -2 minus 4 is -6. Now, what did this tell us? We broke this down into its components. This tells me from where I start, what do I have to do?
I thought that it was 2, 4, not -2, 4.
It's -2 right there. -2 minus 4. Okay, it's right there. So look at this. From this point right here, I've got to go where? -5. You see that? And then I go where? How far down? -6. Now you could have sat there and count over, couldn't you? All right. But what if the numbers were like, 153 this way and 278 this way? Are you going to sit there and count 153 and 200? No, of course not. All right. So we need to know how to do it by the math and not just have to sit there and count over. Would you agree? I think you do. All right. So let's keep going. Now look what we want to do. What we want to do is we want to find this angle right here. So how does knowing this side and this side help us find this angle? Say it, David. You said it. Say it again. All right, the tangent, right. Okay, so look what we have. We have a right triangle here. Now, if you wanted to, without all the junk in there, you could just draw yourself a nice little right triangle. And what are we trying to find? We're trying to find that angle, aren't we? What do we know? We know that length, and we know this length right here, don't we? Okay. And I don't even care at this point anyway. I don't really care if they're positive or negative. I'm just looking at the numbers themselves. Okay. So if I want to find this angle theta, look, I've got opposite and I have adjacent. So that is tangent. That's why he said tangent. So the tangent of theta is equal to the opposite. Which side is opposite this angle? 6. And the adjacent is 5. And now let's one more thing before we put it into a calculator. So theta is equal to, how do we get rid of that tangent? Take the inverse tangent, which looks like that, of 6/5. Okay, get the calculator out, clear it, and it is because I had it saved from earlier. So I hit second function tangent right there of 6/5. 6/5, or 6 divided by 5, equals, and it's 50.2, but in degrees we just keep it rounded to the nearest degree, so that would be 50 degrees. So that's equal to 50 degrees. Well, that's not my answer. That's not my direction. What is it? This angle right here is 50 degrees. Let's get rid of some of this junk. And let's get rid of that right there. So what's this angle right here? That's 50 degrees, isn't it? But what's the whole big angle? What's my whole direction? Look, I start from here and I have to go all the way around to here. So if this little bit is 50, what did I say at the beginning? You went how far? 180, what? Plus 50. So our direction is 180 plus 50, and that gives you 2, how about 30? Work on your addition. Okay, so 230 degrees. That is my direction. That's the final answer that I want for this problem. Because if I just said 50 degrees, where would 50 degrees be? 50 degrees would be like that. Actually, it would be in the same direction. But it'd be like that. That's 50 degrees, isn't it? Right there. Is that the angle that my vector's going? No, it's not going 50 degrees. It's going 50 degrees plus another what? 180. Does that make sense? So really, the direction is 230. So if I said, okay, you're going to go 230 degrees. Well, you start here. This is 0 degrees. And then this would be what? 180. And so you go 180 plus how much more? 50 more. Okay, 50 more. So you go 180 plus the 50, and that gives you the 230.
When someone says you have to go 180 degree turn, does that mean you have to like do a U-turn?
Yeah, so, I mean, this is where you're originally heading, right here at 0 degrees. If they say, you've heard people talk about this as far as turning their lives around, you know, oh, he turned his life around 180 degrees. What does that mean? Well, he was going that way. Now he's going what? He's going completely the opposite direction. I've actually heard people say, oh yeah, this kid, he's such a good kid. He's turned his life around 360 degrees. And I cringe when I hear that. Because what would 360 degrees be? Ain't going the same place as he was going originally.
Well, that's good.
Well, if you were doing good to begin with, but that's not what they mean. They mean they were heading for a life of crime and sin and despair, but now he turned his life around, so now he's heading for a life of good things, right? But when you say 360, he's going back in the same direction where he started. Okay, that was the bulk of what we have to do. All right, let's do an example where we kind of put a lot of this stuff together. All right, let's do the example from the book. This is on page... Did I say the other one was 594?
Yeah.
Oh, yeah, I did too. This one is... I got to flip the page. This one is 596, okay? So it's page 596. It's a word problem. Now, they go through all this stuff, but basically it boils down to this. You got somebody shooting off these shirts. You ever see these T-shirt things and you have the guns and they shoot them into the crowd? Okay, shh, let's not do this. All right, you do this all the time. Let's just listen and pay attention. It says if a shirt leaves the launcher at 40 feet per second at an angle of 45 degrees. So what we're going to do is this. Let's make my X and Y axis. We'll just make it white. We have two different situations here. And let's do my right here. It's leaving at 45 degrees. So 45 degrees is about right there. We don't have to be perfect. Shoots it at 45 degrees, but there's a problem. It's outside and there's a wind blowing. And the wind is blowing in the, it says parallel to the horizontal. So here's the horizontal, so the wind is blowing completely horizontally and it's pushing it that way. So even though you angle it this way, is the shirt really going to go that way? No, the shirt's going to actually veer off like this, isn't it? You see it? Because if the wind is blowing from the left to the right, completely horizontally, if you shoot this shirt off like this, what's going to happen? The wind is going to push it, so really the shirt's going to go kind of in that direction, isn't it? Well, I don't want to get too confusing. What we're going to do is we're just going to add those two vectors together. So this is 45 degrees. And what's the velocity? What speed does it leave? 40 feet per second. That's my magnitude. Remember we talked about that yesterday? It's how fast. So this is 40 feet per second, or we'll just call it 40. Now the length of the line should be indicated by the number. So if this is 40, now the air speed is not near as fast. What's the air speed on that problem? Anybody see it? I think it's 7, I believe, isn't it? Anybody looking?
Yeah, it's air speed, 7 feet per second.
Okay.
Science would be doing meters. Well, not science.
Yeah, they do feet per second. I mean, you could do it all kinds of different ways, but watch this. Let's do the same color. Let's grab that. Let's make it a little bit bigger. Okay, and here we go. Watch. Let's just say it starts from the origin and it goes to the right. Now, it's got to be a little bit of a smaller line than the 40, right? Because it's only going 7 meters or feet per second. Okay? And let's go back to 1. Okay, so that's 7. Now, it's going completely horizontal. So what's my angle right here? It's 0 degrees, isn't it? Okay, it's just going 0 degrees. So 0 degrees. So look, I got two things. What I'm going to do is I'm going to add these two vectors together. And you say, how in the world do you add vectors together? Well, it's actually very easy. Listen to me. It's actually very easy to add vectors if you break them down into their components. Remember we did that with the little arrow bracket things? Okay, if you can break this down into its components, then it's very easy to add the two things together. I'll show you. So let's take this and break it down into its components. And how do we do that? Well, we have to take this point, which is where? What's that point right there? Nobody talking to me today? That point right there. It's the origin. So where is it? It's 0, 0, right? Okay, it's just at the origin. What about this point right here?
XY.
Yeah, we don't know what it is, do we? All right? So we'll call it XY. We don't know how far it is. So what do you think we're going to have to do? Well, we're going to have to figure out these two lengths. And how in the world do we figure out the two lengths? Can't do distance formula because I don't know this point. Yeah, use the trig function. So watch, what I want to do is I want to make a triangle out of this thing. So I'm going to take this, put it right underneath of there, and then go right up to there, make a triangle out of it. Everybody see that? Let's make it a little bit thicker just so you can see it. Alright, so there's our triangle right there. Oh well, you get the idea. So what we have to do is we got to solve for x and we have to solve for y. So let's see, we're going to use our trig functions. The other class was yelling off law of sines, law of cosines, but we don't need law of sines and law of cosines when we have a right triangle. It's a lot easier when we have a right triangle. So let's take a look to see what we're going to use to solve for x. Well, this is adjacent, right? And this is hypotenuse. Which trig function uses adjacent and hypotenuse? That's all three of them. You can't just say SOHCAHTOA. This is the cosine, all right? It's adjacent over hypotenuse. Try just listening for a couple minutes, Matt. That might help you a little bit, okay? No, you've been, everything I say you have a comment to make. Just take it in for a second, okay? So watch, the cosine of 45 is equal to the adjacent over the hypotenuse. So it's x over 40. So let's solve for x. Multiply both sides by 40. So x equals 40 times the cosine of 45 degrees. Plug into a calculator real quick. So it's 40 cosine of 45, and that's about 28.3. Okay, so 28.3. We'll just keep it like that. Okay. Now look at this. You could actually do this kind of quick. This is a 45, 45, 90. You already saw it, didn't you? 45, 45, 90. What's true about the two legs on a 45? They're the same. So I don't even have to go through the math, do I? All right. I could if I wanted to, and you'd find out it's exactly the same because the cosine of 45 is the same thing as the sine of 45. And it's going to be exactly the same. So y is also equal to 28.3. Why did we even care what the lengths of those were? Because we wanted to find this ordered pair up here. So we could break it down into its components. So this is 28.3 and this is 28.3. So this is pretty easy because it's this minus 0 and this minus 0, right? So when it's not squared, there's nothing squared. All we're doing is we're breaking it down to its components. Remember, it's just x2 minus x1 and y2 minus y1. This is x2 minus x1, so it just comes out to 28.3. And this is 28.3 minus 0, which is just 28.3. That's the component form of this. I just took this vector, broke it down into its two components. I had to use some trig, didn't I, to get to that point. What about this one right here? This is actually a lot easier. First of all, what's the ordered pair where it's starting? What about where it ends? 7, 0, right, because you went over 7 and you didn't go up at all, did you? So that's just 7, 0. So what are my components to this? Well, it's x2 minus x1, which is 7, and it's y2 minus y1, which is 0. So there's my two components. Now, what did I say I wanted to do to these two vectors? I wanted to add them up. Once you break them into its components, it's really easy to add them up. So what do you think we add up here?
The x and the y.
The x's together and the y's together. So add the x's. 28.3 plus 7. What's that? 35.3. Okay? And then add the y's together. That's easy. It's 28.3. Okay? Now that right there is the addition of those two vectors. But guess what they want you to do? They want you to find the magnitude and direction. So guess what we're going to have to do to this? Nope. We're going to have to do exactly what we did earlier. Only got a few minutes here, so we'll probably get about the same place as I did the other class. We almost finished in the other class. Okay, look. This means basically we're starting here. Okay, let's go a different color. We'll have them used. Let's use blue. Oopsie daisy, what's that? Okay. Look, basically we're doing what? We're going over 35.3, right? So let's just estimate. That's 35.3. And then this is 28.3, so probably about right in there. Is that all right with you? So that point right there is where we end up. So where do we start? From our origin, where do we end up? We end up right there. So what are we trying to do? We're trying to find magnitude and direction. So how do we find the, and let's see, what's this point? This is 35.3. This is 28.3. Magnitude and direction. How do we find the length of that line right there? Okay, we can make a triangle, but we don't even need a triangle to find the length of that line, do we? Just do the what? Distance formula, right? Man, you're driving me crazy today. All right, what is with you?
I just said it looks funny.
I know, but you said 100 things today. It's one of 100. Look, let's do the distance formula. This minus this squared is just what? 35.3 squared plus 28.3 squared. Throw that into a calculator and you get whatever you get. Let's do it real quick. 35.3 squared plus 28.3 squared equals, and then let's take the square root, right? Square root of the answer, right? Square root of the answer. Oh, that's not what I wanted to do, is it? What did I hit? Did I hit something? Oh, I hit that accidentally, didn't I? So I hit second function, that. Oh, there we go. Yeah, I accidentally hit that thing. Just like you said. 45.2. Alright, so 45.2. I just wanted to show how to do it. Okay? That's my what? That's my magnitude. That's how long this line is right here. It's 45.2. What else do I need to find? The direction. So I need to find that angle right there. So watch, I just drop this straight down right here. And how do I find the direction? Well, I know two lengths, don't I? Actually, I know all three lengths. I know this is 28.3. I know this is 35.3. So I can use any trig function that I want. So let's just use the tangent. We use the tangent a lot with this. So I'm going to use the tangent is equal to the opposite over the adjacent. Take the second function. I don't have to write that down, do I? Oops. Right, just take the inverse tangent. So watch. So inverse tangent of 28.3 divided by 35.3 and then equals 38.7. It's an angle. We'll round it to the nearest angle. We'll say 39 degrees. So theta is about 39 degrees. And there it is. Look at that. That was a lot of work, wasn't it? The more you do it, listen, the more you do it, the better you're going to get at this. But there it is, okay? If you need to review it, please review it. I know we went a little quick at the end, but we actually did finish. I just got to this point, and I didn't put the numbers in. I told the other kids in the other class, you should be able to do the rest of it, okay? But today, we had enough time to at least finish it up in here. All right. So look at this problem. It started off. Actually, it didn't start off that long. It wasn't that bad. It just started off right there. Okay. We just wrote the two. We wrote the two vectors. We found the components of both of the vectors. We added the two vectors together. That was easy, wasn't it? And then we took this one vector and we just found the magnitude and direction of that one vector. So I started back at the origin, right? I went over 35.3 up 28.3, found the magnitude, no big deal, distance formula, found the direction, not that big of a deal, tangent, and bang, I'm done. That's it.
Bang.
That's it. Okay? Look, you guys are going to have to get used to that. You're going to have to get used to doing more than just one or two steps in a problem. When you get to Algebra 2 and Pre-Calc, you'll be doing tons of problems where you're going to be 6, 7, 8, 9 steps. Okay? So there you go. All right. Let me give you some problems to work on. I know you don't want to go away disappointed.
Union and
Here it is. So it's section 8.7, section 8.7, and then pages 597 to 598. Now look, all these problems are not like this, so don't get scared off when you see this, okay? We're doing 8 to 25, but they're not all like this. Some of these are real simple, easy, you look at it, bang, you write down an answer kind of thing. There will be a few where you're going to have to do a couple things like this. But that's why you're in honors, right? All right, have fun with it.